In this video, we want to start to talk about 0 over 0 limits. So we encountered one in the last video where we talked about that really important theorem that doesn't get a name. The textbook where I originally got it from called it Theorem 7. But now we're ready to talk about 0 over 0 limits. And as we saw in that previous video, that previous example, what we're able to do is divide out the zero factor. Divide out the zero factor. And so that's actually the key on these 0 over 0 limits, is we need to divide out the zero factor. Now, part of the work in some of these problems is going to be getting it into the right format where we can cancel out that zero factor. So consider first this example here. This is just another rational function like that previous example. Limit as x approaches 2 of x squared plus 7x minus 18 all over x squared minus 4. And so just like we did before, we want to try and factor. We're looking to see if we can cancel that factor that makes the bottom and top both 0, if we can get rid of that. So we factor the top. And this is just some basic factoring, things that multiply with negative 18 add to be 7. All right, that would be a plus. That would be a plus 9 and a minus 2. And then the bottom there, x squared minus 4, that's just the difference of squares. So I'll factor out as x plus 2, x minus 2. And then we look through and see, right there it is. It's right out in the open for us to see that zero factor, x minus 2. And again, the limit isn't worried about what happens at x equals 2, so that's why we're allowed to cross out that 0 over 0 factor. Because we're not worried about what happens at 2. Limit has no interest in that. So we can cancel those out and then work with what's left. Limit as x approaches 2 of x plus 9 over x plus 2. Well, at this point now we have a rational function, and it's defined at x equals 2. The bottom's not 0 anymore. So we can just evaluate. 2 plus 9 is 11. 2 plus 2 is 4. Okay, so that's the idea. These are by far the easiest ones when we can just factor our polynomials. In the upcoming examples, we're going to see some more things that we're going to need to do.